In this video, we will explain how to work with areas and volumes of similar shapes. The most important step when working with similar shapes is to find the scale factor for the lengths. For example, with these shapes, using these sides, the scale factor from the left shape to the right shape is equal to 12 over 4, which is equal to 3. If you take another pair of sides, for example these ones, then the scale factor comes out to be the same. Note that the scale factor from the right shape to the left one will be 4 over 12, which would give you 1 over 3. So in this case, multiply by 3 to go from left to right, or divide by 3 to go from right to left. You can also find the length scale factor when you have 3D shapes. For example, with these cylinders, you can find the length scale factor by comparing the radii of the cylinders. So the scale factor comes out to be 7 over 2 when you go from left to right. Using the height of each cylinder, we get the same scale factor. 21 over 6 simplifies to 7 over 2. Note again, going from right to left would give you a scale factor of 2 over 7. Once we find the scale factor for the lengths, we can then find the scale factor for the areas and the volumes. I like summarizing these on a table. So, if we call the scale factor for the lengths as k, then the scale factor for the areas is equal to k squared, and the scale factor for the volumes is equal to k to the power of 3. For this example, I will first find the scale factor of the lengths using these two. I'll go from the left shape to the right one, so the scale factor would be 40 divided by 16, which is equal to 5 over 2. So if I summarize everything on a table, I will get this. For ABC, one of the lengths is 12, so the corresponding length on triangle DEF is just 12 times the scale factor, which will give me 30. For part B, the area of triangle DEF is 525, and I want the area of ABC. So now I have to go backwards, so I will divide 525 by the scale factor to the power of 2 to find the area of triangle ABC. This will give me an answer of 84 cm squared. For example 2, I'm given the surface area of the small bottle. I'm also given the area and volume of the large bottle. Now I will summarize all this on my table. So the first thing to do is find the value of k. I will use the areas for this. 240 times k squared is equal to 540. So 540 over 240 will give me k squared. Taking the square root will give me k equals to 3 over 2. Next, I need to find the volume of shape A. I know the volume of B, and I have to go backwards, so I will divide by the scale factor to the power of 3. Put this in the calculator, and you'll get a value of 600 cm cubed. For example 3, I have two regular pentagons, the white one and the whole shape. I am given that EJ, which is this, is 4 times AE. So the side of the large pentagon is 5 times the side of the small pentagon. Let's put all the information we have on our table. So the length for the small pentagon is 1 and for the large one is 5. The area for the small pentagon is 8. Now from here we can see that k is equal to 5. So to find the area of the large pentagon, which I'm going to call x, I just have to multiply 8 by 5 squared. This will give me 200. But that's the area of the whole shape. To find the area of the shaded region, I just need to subtract the area of the large pentagon minus the area of the small pentagon. So this comes out to be 192.